Welcome everyone to the first lecture of Chemical Engineering Thermodynamics NPTEL course. So I hope you have attended the lecture and ready for the problem solving sessions. So let us start with the first problem. So first myself, I am Bharat Dao. I am a doctoral student at the Department of Chemical Engineering, IIT Kanpur. And I would like to thank NPTEL for giving me this platform to teach, and also to the instructor of the course, Professor Jayant K. Singh. So let us start with the first question. The first question is, a typical industrial scale wind turbine. A typical industrial scale wind turbine has a peak efficiency of has a peak efficiency of about 0.44 for a wind speed of 9 meter per second. That is, it covers about about 44%. It converts about 44% of the kinetic energy of the wind approaching it into usable electric energy. Right? The total airflow impinging on such a turbine with a rotor of 43 meter is about 15,000 kg per second for given wind speed. Right? So what are we asked? The first question which we are asked is, how much electrical energy let me just check whether I am audible. Yes, I am audible. How much energy is produced when 1 kg of air passes through the turbine? Passes through the turbine. Second question is, how much electrical energy is how much? The second question is, what is the power output of the turbine? What is the power output of the turbine. Number C, if there is no heat transfer to the air, if there is no heat transfer to the air, and if temperature remains unchanged, and if temperature remains unchanged, what is the change in speed? What is the change in speed upon passing through the turbine? Passing through the turbine. So let us try to solve it. So what we have is, let us read the questions. A typical industrial wind turbine has a peak efficiency of 0.44. So we have been given efficiency of 0.44 for a wind of speed 9 meter per second, and it converts 44% of the kinetic energy of the wind approaching it into usable electric energy. The conversion is from kinetic energy to electric energy, and the efficiency is 44%. The total airflow impinging on such a turbine of rotor, so diameter of the rotor is given, and the mass flow rate of the air has been given as 15,000 kg per second. And what we are asked is how much electrical energy is produced when 1 kg of air passes through the turbine. So what we need the kinetic energy of about 1 kg of air, and if we multiply it with efficiency of 0.44, then what we get, the value which we will obtain, is nothing but the electrical power which you get from it, right? So kinetic energy of the wind on the basis of 1 kg of air, 1 kg 1 kg of air, we can give it as Ek is nothing but half mv square, which is nothing but half multiplied by 1 kg multiplied by the velocity has been given as 9 meter per second. So 9 meter per second square, which comes out to be 9 into 9 by 2. So what we get is Ek is nothing but 40.5 joules. Therefore, electrical energy is nothing but 0.44 multiplied by kinetic energy. It is nothing but 0.44 multiplied by 40.5. Therefore, we get electrical energy as 17.8 joules. Right? So this is the answer of part A. This is part A. Let's now move on to part B. So in part B, what we are asked is, what is the power output of the turbine? So when we say turbine, it means for 15,000 kg of air, right? So that is nothing but power output of turbine is nothing but kinetic energy of 15,000 kg of second of air multiplied by the efficiency, right? Which is nothing but half mv square multiplied by 0.44. Okay, so 0.44 multiplied by half 15,000 multiplied by 9, right? 9 square. 9 square, right? Which corresponds to 267,000 joule per second, right? That is nothing but which is nothing but 267,000 watt, and if you convert it into kilowatt, we get 267 kilowatt, right? The power output of turbine. Comes out to be this much, right? Now, part C. So in part C, we are asked if there is no heat transfer to the air and if the temperature remains unchanged, what is the change in speed upon passing through the turbine, right? So if the temperature and pressure of the air are unchanged, then its internal energy is also unchanged, and changes in gravitational potential energy can also be neglected, right? Hence, what we can write is, so first let me write this: if the temperature and pressure of air are unchanged, if the temperature and pressure of air are unchanged, then its internal energies, then its internal energy is also unchanged, right? Hence, what we can write is change in kinetic energy is nothing but ek2 minus ek1, which is nothing but work done, which is nothing but for 1 kg of air, it's going to be 17.8 joule per kg, right? And so ek2 is going to be what? ek2 is going to be 50.5 minus 17.8, which is nothing but 22.7 joule per kg, right? Which when we convert into units is 22.7 meter square by second square, right? Therefore, ek2, which is nothing but u2 square by 2, nothing but 22.7 meters square by second square. Hence, when we take u2, we get it as 2 into 22.7. Therefore, u2 comes out to be 6.75 meter per second, right? And we already know that u1 is nothing but 9 meter per second. Therefore, change in u is nothing but u2 minus u1 mod. This mod 6.74 minus 9, which is nothing but 2.26 meter per second. Change in speed. Okay. I hope the question is clear to everyone. I'll wait for a couple of minutes if you have any doubts. Okay. Nobody has any doubts? Then we'll move on to the next question. Okay. So the next question is, this one, a horizontal. Question 2. A horizontal piston arrangement. Horizontal piston arrangement is placed in the constant, is placed in a constant temperature bar. In a constant temperature bar. Okay. The piston slides. The piston slides in the cylinder. In the cylinder with negligible friction and an external force holds it in a place against an initial gas pressure of 14 bar. The initial gas volume is the initial gas volume is 0.03 meter cube, and the external force in the piston, the external force on piston is reduced gradually, and the gas expands isothermally, and the gas expands isothermally as its volume doubles. As its volume doubles. Okay? If the volume of the gas is related to pressure, if the volume of the gas is related to pressure such that P to the power T is going to remain constant, right? So then what we are asked is, what is the work done? What is the work done by the gas? By the gas in moving the external force. In moving the external force. Okay. So what we are given is, so we are given a horizontal piston is placed in a constant temperature bath. That means temperature is constant, and the piston slides in the cylinder with a negligible friction, right? So frictional losses are zero, and an external force holds it. External force holds it, right, in a plane against an initial gas pressure of 14 bar, right? So we have horizontal piston with external force, and initial pressure has been given as 14 bar. 14 bar, right? And the initial gas volume is also given as Vi is given as 0.03 meter cube, and the external pressure on piston is reduced gradually, and the gas expands isothermally, right? As its volume doubles. So V2 is going to be nothing but 2 into V1, which is nothing but 2 into 0.03, which is 0.06 meter cube, right? And we are also given that the it is isothermal. The process is isothermal. Process is isothermal expansion. Right? Why expansion? Because the volume is going to get doubled, right? The volume initially it was 0.33, now it's going to be 0.6. Initially it was 0.03, now it's 0.06. That means the volume has doubled, and that is why we are taking expansion, right? And we are also given that PV to the power T is going to remain constant, right? So what we are asked is, we are asked what is the work done? Work done equal to what? So for reversible process, so why we will be taking the assumption of reversible? Because it's a negligible friction, right? So hence we are invoking the assumption of reversible process. We know that work done is nothing but negative of integration from initial volume to final volume PdV, right? So in this case, what's it going to be? You know that we know that PV to the power T is going to main constant. Let's call that constant as K. Therefore, P is going to be K, okay, by V to the power T. Therefore, this is going to be, this is 0.03 to 0.06 K V to the power T into dV. Right? So its integration comes out to be what? This is minus K integration dV by V to the power T, where V is equals to 0.02 to V is equal to 0.06. This implies what? W is nothing but minus K ln of V2 to the power T divided by V1 to the power T. Right? And the value of K is nothing but, where K is nothing but, where K is nothing but V1 to the power T, which is nothing but P2 to the power T. So what is P1? We have been given initial pressure as 14 bar. So 14 bar multiplied by initial volume of 0.03 meter cube, which comes out to be 42000 joules, right? Or if you want me to simplify, 14 bar is nothing but 14 into 10 raised to power 5 Pascal multiplied by 0.03 meter cube. Therefore, therefore, A comes out to be 42000 joule, right? So W is what? We know W is nothing but minus K and then V2T by V1T, right? Therefore, W is equal to minus K into ln of 0.06 divided by 0.03, where we already calculated K value as 42000 pascals, right? At Pascal joules. Therefore, W is nothing but minus 42000 into ln of 0.06 divided by 0.03. Therefore, it comes out to be minus 29112 joules, right? So this is the answer. Right? Anybody has any doubt? I'll wait for a couple of minutes. If anybody has any doubt. Nobody has any doubts? Then we'll move on to the next question. So the next question is, nobody has any doubts? Okay. We'll move on to the next question. So the next question is, in experiments conducted by Joule, okay, question number 3. In experiments conducted by Joule, experiments conducted by Joule or Joule, energy is added to water as work. Energy is added to water as work, right? But extracted from the water, as heat. So between the time it is added to work, So between the time it is added water as work and the time and the time it is extracted as heat. It is extracted as heat. It is contained. It is contained in the water in the form of what? The options are there. The option A is kinetic energy. Option B is potential energy. Option C is internal energy. And option D is heat. So which of the following is correct option? I will give a couple of minutes for you to think. So for example, what we have is, let's say we have a container like this, like this. This was its initial position. This is initial. This is final, and it has water. So this is water. Now what it is being done in Joule experiment? What we are doing is we are adding is added to work. So we are adding work into the system, right? Right. However, when we as a final thing, what we do is we extract this work. Let's say work is added of this particular quantity. Let's say, for example, we are adding 10 units of work. 10 units of work are added, and similarly, after some time, 10 units of work are only extracted in the form of heat, right? So by the time, let's say this is a time t equal to 0 second, and for simplicity, this is a time t equal to 10 second. So for from point 0, 0 seconds to 10 seconds, the heat is going to contain in the water in which form? Right? That is what we are asking. Whether it's kinetic energy, so whatever amount of work which we are adding, is the kinetic energy of the system going to increase, or the potential is gonna energy is going to increase, or the internal energy is going to increase, or the heat is going to increase. Right? I hope the question is clear to everyone. If you have any doubt, you are free to ask. Anybody has any answer? Nobody has any question answer. The correct answer is option C, right? It's going to remain in the form of heat energy, internal energy. Okay. So the next question number 4. So again it's related with the experiment conducted by Joule. In experiment conducted by Joule, so if you have listened to previous question carefully, the answer is hidden in that question only. Energy is added. Energy is added to water as a in the blank and but extracted from the water as dash. The correct first option is it is added in the form of, for example, A is going to be work and B is also going to be work, or A is going to be work, B is going to be heat, C, A is going to be heat, B is going to be work, or D, both A and B are going to be heat. So if you have listened to the previous question carefully, so here what we have, energy is added to water in the form of work and extracted as a form of heat, right? Which of this correct, what is the correct answer? Work and heat, right? So option B is the correct answer, right? Anybody has any doubt? I'll wait for a couple of minutes. If you have any doubts, if nobody has any doubt, then we'll move on to the next question. Okay, nobody seems to have any questions. So we'll move on to the next question. So the next question is like this. Question is question number 5. A horizontal piston, a horizontal piston arrangement is a piston arrangement is placed in a constant temperature bath, in a constant temperature bath, right? The piston slides in the cylinder with negligible friction. The piston slides in the cylinder with negligible friction, and an external force and an external force pulls it in place, in its place, against an initial pressure of against an initial pressure of 10 bar. The initial volume, the initial volume is 0.04 meter cube, right? The external force on the piston is reduced gradually. So now this is very important one is, so we have option 1 in which we have this is reduced gradually, and in another case it's reduced suddenly, right? Reduced suddenly. So these are the two cases. What we have is, what is the, in both the cases we have to find the work done. What is the work done by the gas, in moving, so by the gas, if the volume of the volume of the gas is related to pressure, is related to pressure, like this, P into V is constant. Yes, P into V is nothing but constant. So what is this work for first case, which is in which it reduces gradually? So hint is here is if it reduces gradually, that means this is a reversible process. Whereas when it is reduced suddenly, that means it's a reversible process, right? So this question is basically designed to test your knowledge or understanding of whether you understand the concept of reversible process and irreversible process or not. Right? So the options are like this: 20,000 Ln2 joules. Option B, 0.2 Ln2 joules. Point C, 20,000 joules. Or point D, 40,000 Ln2. What is the answer? So I'll give you 5 minutes for you to solve about for you to solve. So you have to solve for both the cases. Reduce gradually and reduce suddenly. If anybody does not understand, so this question is similar to the first question which we had, right? Sorry, the second question which we had. This one, right? The question is similar to this question. Understand that this question was reversibly, right? So whatever, whichever form, and the relationship is also the same. P into V is going to remain the constant. So whatever expression we derived, so this expression which we derived in here, it's going to remain for the reversible part, right? But what about the irreversible part? Right? This is the irreversible part. So you have to solve for both the things, right? So I'll give you 5 to 10 minutes to solve this question. If anybody has any doubt in understanding the question, they can ask. And those who have understood can start solving. Anybody got it? Anybody has any questions? So anybody has any question? For the reversible case, let us try solving. So for the reversible case, this is first case, we will use the same expression which we have calculated in here, which is minus WK ln V1 or V2 by V1, right? Let us write this down. This is the expression for case 1, right? Case 1. Let us write like this. So case 1, reversible. So what we have is W is going to be this, right? So what are we being given? We are given P1 as 10 bar and V1 is 0.04, right? Therefore K is nothing but PV, which is nothing but 10 into 10 to the power 5 multiplied by 0.04, which is nothing but 4 into 10 to the power 4, right? Which means 40,000, and therefore W is nothing but minus 40,000 multiplied by ln of. So the what is the final volume? So final volume is what we have is 2, right? So V2 is 2 times V1 multiplied by V1, right? Therefore W is nothing but 40,000 ln 2, right? So for the first case, the answer is going to be what? Option D, right? Right? It's going to be 40,000 ln 2, right? Is minus. So when we say minus, it's work, right? And when we say work done, so work done is going to be this one, right? This is the work done. When we say work done, the minus sign is going to get removed. So work done is going to be this. Now for this case 2, which is irreversible. So in that case, work is going to be W is going to be minus integral PdV, which is the what? As the pressure is suddenly reduced, dV, which is minus P V2 minus V1, which is nothing but minus 10 10 raised to power 5 multiplied by 2V1 minus V1, which is minus 10 10 raised to power 5 multiplied by V1, which is nothing but minus 10 10 raised to power 5 multiplied by volume is 0.04, right? Therefore, in that case, work done is going to be 40,000, right? For this, the correct answer is sorry, the correct answer is going to be 40,000, right? So let us move on. I hope the answer is clear to everyone. Let us move on to the next question, right? If you have any questions, you can ask me. I'll wait for a couple of minutes. So I'll wait for a couple of minutes. If you have any doubts, you can ask it. Else, if you somebody wants to write this down, they can write this down as well. So nobody has any doubts? Nobody has any questions? So we'll move on to the next question, right? The next question is question number 6. The specific volume of liquid water. The specific volume of liquid water and water vapor at 100 degrees centigrade and 101.325 Pascal, kilopascal, 101.325 kilopascal are 0.001 and 1.673 meter cube per kg respectively. Right? Heat in the amount of heat in the amount of 22569 kilojoule is added to 10 kg of water to vaporize it completely at the constant temperature of at the constant temperature of 100 degrees centigrade and constant pressure of constant pressure of 101.325 kilopascal. The change in internal energy for this process is option is 2 to 22569 kilojoule. Option B 20875 kilojoule. Option C 22399.6 kilojoule. And option D is 24263 kilojoule. Right? So I'll wait for a couple of minutes. I'll give you a couple of minutes to solve the question. If you have any doubts, you can ask me. And those who do not have doubt, they can start solving the question. Anybody has any doubts in the question? Anybody able to solve it? Anybody got any answer? So the correct answer is option B. Right? Correct answer is option B. The solution for this is what we have given is 10 kg of water is taken as system, right? And at a amino at constant pressure, Q is nothing but n into delta H. This is nothing but 22569 kilojoule. This is given, right? And we also know that L into delta is nothing but L into delta U plus N into P delta V, right? Therefore, rearranging what we get is N delta U is nothing but N delta H minus minus N P into delta V, right? It is nothing but 22569 minus 10 into 101.325 into 1.673 minus 1 point minus 0.001, right? This all we are calculating in kilojoule, which comes out to be at 20875 kilojoule, and delta U. This is the answer. Now, if instead of this, if we make a slight change, so first of all, does anybody have any doubt in this? Everybody is able to understand it. If you're not able to understand, please ask. But instead of this question, if we make slightly tweak this question, so is that question 7. Instead of this, if we do it at, for example, now instead of this, if we ask what is the change in, we are changing internal energy instead of internal energy. What is the change in enthalpy for this process? And what's it going to be? Everything remains the same. Just we are instead of changing entropy, so change in internal energy, we are going to ask for change in enthalpy. The options are going to remain the same. Right? So what is the answer for that? I'll give a couple of minutes to think. I hope everybody got the question. If you have any doubt, you can ask. Anybody got the answer? Anybody got any answer? The correct answer is is 22569, right? It's going to be option A, right? Because we already knew, right, that 10 kg of water is system here, right? And we know N into delta H is nothing but the at constant temperature, at constant pressure, heat added is nothing but change in enthalpy, right? This is nothing but delta Q. And we are already told that delta Q is nothing but 22569 kilojoule. Therefore, change in enthalpy is also going to remain as 22569 kilojoule. I hope the question and solution is clear to everyone. If you have any doubt, you can ask me. Else, we'll move on to the next question. So the next question is a bit simple one. Heat in the amount of in the amount of 8 kilojoule is added to a closed system while its internal energy decreases by 12 kilojoule. Work done, then in that case, work done, remember this is work done by the system is option A 20 kilojoule, option B minus 20 kilojoule, option C 4 kilojoule, option D minus 4 kilojoule. So remember it's work done by the system, right? So I'll wait for a couple of minutes for you to solve the question. I hope the question is clear to everyone. And if anybody has any doubt, they can ask. And those who have understood can try solving the question. Anybody got any answer? The correct answer is option A. It is 20 kilojoule. Why? So here you have to be wary of the convention which we use, right? So we know delta Q is nothing but change in energy is nothing but change in work plus change in heat. Therefore, W is nothing but delta U minus Q. So here what we have is 8 kg of heat is added. That means Q is going to be plus 8 kilojoule and internal energy decreases. That means delta U is going to minus 12, right? So it's going to be plus 12 minus of plus 8, which is 12 minus 8, right? Sorry, it's going to be minus of 12, right? It's going to be minus 20. But since they are asking work done, so in that case, W is going to be mod W, which is nothing but mod of minus 20, which is nothing but 20 kilojoule. Hence, the option is option A. Okay. If W is nothing but 20 kilojoule. So this is the answer. Okay. So I hope the question and solution is clear to everyone. If this is clear, then we'll move on to the next question. Right. So the next question is on the similar lines. So what we are given is we have to calculate change in internal energy and change in enthalpy for 1 kg of water when it is vaporized at constant temperature of 100 degrees centigrade and constant pressure of 101.325 kilopascal. The question is similar to the one which we have solved. The specific volume of liquid and vapor water at these conditions are 0.00104 and 1.673 meter per kg. Okay. And heat in the amount of 2256.9 kilojoules added, right? It's a similar question. We clearly know that at constant temperature and pressure, delta is nothing but Q, change in heat, which is nothing but 2256.9 kilojoule, and delta U is nothing but delta H minus delta PV, nothing but delta H minus P delta V minus B delta P. So yes, pressure is going to be remain same. That's why it's going to be delta H minus P delta V. And when we put in the values, we get this is nothing but 2256.9 minus 101.33 multiplied by 10 to the power 3, 1.673 minus 0.001, which corresponds to delta U is nothing but 2087.5 kilojoule, right? So I hope that both the question and answer is clear to everyone. So I'll give you a couple of minutes to solve this, to understand this, and if anybody has any doubt, they can ask. Anybody has any doubts? Now let us move on to the next question. Question number 10. Which among the following is not an intrinsic property? Right? Option A is mass. Option B is specific heat capacity. Option C is density. And option D is pressure. Right? So just remember, just a reminder that extrinsic property which depend on mass and intrinsic properties are which do not depend on mass of the system. So which of the following is not an intrinsic property, right? So I'll give you a couple of minutes to solve it. So what we have is here is which is not an intensive property. It means we need a property which is extensive, right? That means which depends on mass. What depends on mass? So mass depends on mass. Specific heat capacity does not depend on mass. Density also does not depend on mass. Pressure also does not depend on mass. So the correct answer is option A. Anybody has any doubt? So let us move on to the next question. Question 11. A system that does not allow transfer of mass between system and surroundings is known as option A, isolated system. Option B, closed system. Option C, open system. And option D, none of the above. I'll wait for a couple of minutes for you to solve the question. Anybody got the answer? Anybody got the answer? No, the correct answer is option B, right? Closed system. Because so a system that allows both mass and heat to transfer is open. So for open system, delta M is non-zero. Similarly, delta Q is also non-zero. Then for closed system, it does not allow transfer of mass, right? Transfer of mass is zero, but delta Q may be non-zero. And isolated system is delta, it does not allow mass and also heat to transfer, right? So as per this, that does not allow transfer of mass between system and surrounding is called as closed system, right? Question number 12. A system that permits both matter and energy between system and surrounding between system and surroundings is known as, again the same option, isolated system, closed system, open system, and D, none of the above. I'll give you a couple of minutes to solve it. The correct answer is option B, right? Option C, right? Open system. You see that both mass transfer and heat transfer is allowed, and that is what is asked in here. Okay. So let us move on to the next question. Question number 13. Question number 13 is, which among the following, which among the following, when in operation, is an example of an isolated system? Option 1, heater, boiler, thermoflask, frying pan, and number D, air conditioner. Right? So I'll give you a couple of minutes to think. So the correct answer is option C, right? Thermoflask. Just move on to the next question. It is option number 40. If the direction of the process, if the direction of the process can be reversed, at any point by an infinitesimal infinite decimal change in external condition, then the process is known as whether it's a reversible process or irreversible process or partially reversible or none of the above. So I'll give you a couple of minutes to think on it. So note that direction of the work can be reversed, right? Can be reversed. That means it's clearly a reversible process, right? Let us move on to the next question. Property whose value in prescribed state is independent of previous history previous history of the system is known as option A path function, option B state function, option C both of the above, option D none of the above. Clearly, path functions are the properties which depend on the path. For example, Q and W, and state function are the properties which do not depend on the path. Right? So those are independent of history of the system. Hence, the correct answer is option B, which is state function. Right? So now let us move on to the next question. Question number 16. And the final question for today is internal energy change. Internal energy change of a system over one complete cycle. Over one complete cycle in a cyclic process is option A 0, option B positive, option C negative, and option D is depends on the particle. Right? Correct answer is obviously option 0. Now why? Because internal energy is a state function, right? And state function depend only on initial and final position. As the process is cyclic, the system comes back to its initial state. Hence, the change in internal energy is zero, as E initial is nothing but E final, because of which E final minus E initial is nothing but 0. So this is it for today. So I thank you all for attending this class, and I hope to see you all again in the next class. And if you have any doubts, you can always ask me in the next class. So thank you all. So I'll wait. So those who have no doubts, they can leave. And if anybody has any doubts, they can ask now. I'll wait for a couple of minutes. Right. If those students who do not have any doubts, they can leave. So nobody has any doubts. Okay then. So I thank you all for once again. I thank you all for attending this class, and I hope to see you all again in the next class. Thank you.